Good afternoon, everyone. Thanks for coming to this discussion section. Today, we will work on problems related to sets and set proofs. So, let's start it with the first one. Use a Venn diagram to check the correctness of set operation. I will give you 1 minute to think about it, and we will try to solve it together. Okay, let's start from the left-hand side. Oh. There are 3 sets A, B, C in this statement. And firstly, we should draw a square to represent the universal set U. And A, B, C is in the universal set. In the left-hand side, there is an operation B union C. So we can put lines in B and C to show that elements is either elements come from set B or set C. And we have A. We have the same U set universal set A U set A, set B, and set C. And this is represent set A. And finally, we can get the left-hand side operation. The relative component of A respect to B union C. So the relative complement means that the elements of set from B union C, but it is not in A. So we should be careful that we can drawing some lines in B and C, but not in A. So here is the Venn diagram for the left-hand side. Then for the right-hand side, there are 3 main operations that are B minus A, C minus A, and the union of these 2. Remember, we always need to draw 3 sets A, B, C, and the universal set B, relative complement of A respect to B, that we can draw lines in B, but not in A. And here we draw lies in C, but not in A. Then it's the union of previous two. The union of this one and this one. So this is the Venn diagram for the right-hand side. Next, we should take a look at these two and got a conclusion. So we say the statement is true because left-hand side and right-hand side are equal. We are done with this proof. Any questions so far? Good. Let's go to the next question. So it's a set proof problem, and please spend 2 minutes to think about it first, and then we'll do it together. And here is a key hint. Because we need to prove a set is a subset of another set. For example, if you want to prove P is a subset of Q, you will choose X from P, and then you want to prove X is also in Q. That means whatever element you choose from P, it should also be an element in Q. That is the process to prove that the set P is a subset of Q. Let's start it. So we choose an element from the left-hand side. So that X is an element of A union the intersection of B and C. By the definition of union, X is an element of A, or X is an element of the intersection of B and C. This is, we get this conclusion from the definition of union. So because we have two cases, we can prove it by case. Case 1, X is an element of A. And the case 2, X is an element of the intersection of B and C. So if in the case 1, when X is an element of A, by the definition of union, X can be an element of A union B. Any question about this statement? Okay, X is also, by the definition of union, X is also an element of A union C. Here is a question. Can we just distribute the left side to show it's the same on the right? No, actually, good question, but the left is not the same on the right. The left is this means left is a subset of the right. So if you draw a picture, this means the right, then the left is just a subset of that. So you cannot use the equivalence table to prove it because you cannot prove it. But if you can prove when you pick X from the left-hand side, whatever left-hand side X you pick from the left, it is also belongs to the right, then it means the left is the subset of right. So it means the sets are logically equivalent. Let's take a look at the equivalence table. Okay, yes, they are the same. Yes, they are the same, but although A is equal to B, then A is a subset of B. B is also a subset A. This one is equivalent to these two statements. Yes. Yes, but in this, okay, yes, you can do that. This is a good point. Yeah, you can do that. But in the exam, there always exists some question to show a set is a subset of another set. So you can prove to show their equivalence. But in this problem, I will show how to use our case proof by case to show a set is a subset of another one. Yes, good catch. No problem. Thank you. Any question is welcome. So yes, in this problem, you can use to show that they are equivalence. Then it also show that it is a subset of another one. Yeah. Thank you. Then, let's start from here. Because X is a subset, but because X is an element of A union B, and it is also a element from A union C. So by the definition of intersection, X is an element of A union B intersects A union C. Okay, then let's go to case 2. By the definition of intersection, we have X is an element of B and X is an element of C. Then, by the definition of union, X is an element of A union B, and X is an element A union C. Then, by the definition of intersection, X is an element of A union B, A union C. So we are done with the 2 cases, but we still need to write down our conclusion. In either case, X is an element of A union B intersect A, C. Therefore, A union B and C is a subset of A union B and A union C. So we are done with this proof. Any question about this problem? Okay, let's go to the next question. So prove these set operations using the equivalence table. Let's use 1 minute to think about it, and then we will solve it together. Okay, sorry, I needed to make a comment. In the previous problem, you cannot use the equivalence table directly because it is required to prove it. So maybe in the future, you will also need to prove this statement. So if it asks you to prove this statement, you should prove it step by step. Just like this one, if you want to prove this 2 is equal, then you need to prove this is what we did in our last question. But you also need to prove so if you see a question that asks you to prove like this, please prove it step by step. Don't just cite the equivalence table. Okay, let's get started. We start from the left-hand side. The left-hand side is A union A complement intersect B. So we can use the distributive. It is equal to A union A complement intersect A union B. And this is B distributive. And then because we can find this one in negations, it is equal to universal set A intersect A union B. And this one is by negation. And from this one, in this sentence, U is the universal set is on the right, so we needed the commutative to switch A, B. U. This is commutative. Then it is equal to A union B by identity. So we are done with this question. So although this one is very simple, but do not skip it. When the question asks you to prove it by the equivalence table, please do not skip any step. Any questions so far? Okay, let's go to the next one. This is a problem that to prove a set is the subset of another one. So please think about it for 2 minutes. Okay, let's get started. Let's start from the left-hand side. As we discussed before, that we should choose an element from the left-hand side and then to prove that this element is also belong to the right-hand side. So that X is an element from the intersection of these two sets. This is different from the previous problem because it is the intersection of two sets, not the union of two sets. If it is a union of the two sets, we can prove it by case. But if it is an intersection, it requires the element to satisfy the requirements of both sets. So we cannot prove it by case, but we can know X should be equal to n squared minus 1, and also X should be equal to 2k, where n and the k is an integer. Then, because these two are the same, we can write n squared minus 1 is equal to 2k, and n squared is equal to 2k plus 1. I think everyone is very familiar with these functions. So by the definition of odd, n squared is odd. And because n squared is odd, this means n is odd. Then still, by the definition of odd, there exists a p that n is equal to 2p plus 1, where p is an integer. Okay, and then we can rewrite x is equal to n squared minus 1, and because n is equal to 2p plus 1, so x is equal to 2p plus 1 squared minus 1 is equal to 4p squared plus 4p plus 1 minus 1. It is equal to 4p squared plus p. It is equal to 4n, where n is an integer. This is by the closure property of integer under addition and multiplication. Okay, I will write it down. So X belongs to the set because we choose an element from the left-hand side and show this element is also belong to the right-hand side, so we can make a conclusion. Therefore, it's a subset of this right-hand side. Oh. Done? Any question about this question? Okay, let's move on to the next question. rewrite it to Boolean algebra notation. So first, let's recall the Boolean algebra. There are three operations in Boolean algebra. That is, this means and, this means or, and this is not. And the corresponding operations in the set is and is intersection, is union, and not is complement. Then let's use 1 minute to rewrite it, and we will solve it together. Also, here is a hint. We have the relative complement operations in the original statement. So the relative complementation B respect to A is the same as A intersection, the intersection of A and B complement. Because we don't have the relative complement in the Boolean algebra, so we need to rewrite the original statement. The original statement is it is the same as A intersection B intersects B. So we should rewrite the original statement based on this operation. Then we can write the Boolean algebra of that. And please notice that the uppercase of ABC is represent sets, so we cannot use uppercase of it. So we can choose the lowercase of it. It is A and B and B and C, not A and B and not C. So we are done with this problem. Any question about this problem? Okay, let's go to the next one. Please use the Boolean algebra to prove that if A and B is equal to A, then not A or B is equal to 1. So please remember that the rules of the set theory is the same with the Boolean algebra. So if we rewrite that is for example, in here, that is A and B is equal to B and A. So we can still use these equivalence tables to prove the statement. Okay, let's start it with not A or B. It is equal to A and B, not A and B or B. And this is because AB is equal to A. So for these items, we can use the De Morgan's law. If we rewrite De Morgan's law in the algebra, in the Boolean algebra, it will be A B not is equal to not A plus not B. So it is equal to not A plus not B plus B. This is by De Morgan's laws. Then it is equal to plus this one. This is associative. And we want to use the negation, but we have the not A on the right, so we need to switch it. This is commutative. Then it is equal to A naught plus U. This is negation.
I think you mean 1 instead of the U there.
Oh, yes, you're right. then it is equal to 1. This is by the universal bound. Any question about this problem? Yes, we should have this. One is corresponding to the empty set, and one is corresponding to the universal set. Okay, this is the last question, that to show that ABC is a partition of the integer set. Let's use 2 minutes to think about it, and then we will solve it together. Let's recall how to prove that prove a partition. So if you want to prove it is a partition, you should prove there are 3 steps. Firstly, you need to prove A, B, C is not empty. And second, you need to show A, B, C and A, B, and C do not overlap. And third, you need to show the union of these 3 is equal to the integer set. So if you want to show that ABC is a partition of C, you need to have 3 steps in your proof. The further step is simple. Firstly, you can find 2 is an element of A, and 1 is an element of B. 3 is an element of C. Therefore, A, B, and C are not empty. Secondly, you need to show A, B, C don't overlap. You can take a look at the B and C. It is very like the format that comes from the integers that it is divided by 4. So by the division theorem, every integer can be written as 4k plus 1, 4k plus 2, and 4k plus 3, while k is an integer. Then any integer in the form of 4k or 4k plus 2 is from set A. Do you agree? Okay, so then any integer in the format of 4k plus 1 is from set B. Similarly, any integer in the format of 4k plus 3 is from set C. So A, B, C are not overlap. Because this 4 is not overlap, so A, B, C is not overlap. And thirdly, we needed to show the union of these 3 is equal to the integer. Actually, we have already done that. But you still need to write it down. And from these 3 steps, we can make a conclusion. Therefore, A, B, C is a partition. So we are done. I think this is the last question. Okay. Any other questions or on these questions or on the previous question? If no, we are done. Thanks for coming to this discussion section, and thanks for coming to our TA office hour.